In example 4, we sort of come back to where we started. When we started off with the machine A and machine B, and machine B broke down and we had to buy new super machine C. If we have a function f of x, so here is f of x. I won't necessarily label. If we have two functions, one machine here, a blue machine, and then a green machine, and you put a number in, something would go into the first machine, pop out a number. That second number would go into the second machine and pop out another number. And what question 4 is asking, can you find that super machine that does both at once? So for example, in A, it says find f of g of x. So that would mean you would do g of x first. So that would mean our blue function is g of x, which is 2x plus 7. And then you would do f of x after that. So our green function is f of x, which is 2x squared plus 1. So if you plugged in, for example, a 5, out would come 17. Why did I pick a big number? If you plugged in a -1, out would come a 5. And then if you plugged in 5 squared 25 times 2 plus 1, out would come 51. And so the question is, what function here in red would do that same thing? Plug in a -1 and out would come a 51. The way that we figure this out is we actually plug in a random number. We say, let's plug in x. If I plug in x, what comes out of the blue machine? 2x plus 7. And if a 2x plus 7 goes into the green machine, the green machine says whatever you put in gets squared, doubled, and then you add 1. So if you put in a 2x plus 7, it would get squared, then doubled, and then you would add 1. And that is the equation of our super machine. Well, you could expand it if you wanted to and simplify that. Sometimes we will, sometimes we might just leave it like that. So sure enough, if you plug -1 into that, you get 51. Now, we're not going to draw pictures like this every time to solve these. We're going to look, how do we write this algebraically? So if I want to find f of g of x algebraically, so here in part A, this says first plug x into g of x. Well, if you plug x into g of x, what came out? A 2x plus 7. And then plug 2x plus 7 into f of x. So I'm going to just rewrite f of x off to the side here and highlight the fact that what a function says, it tells you whatever you put in, what happens to what you put in. In this case, if whatever I put in, which is highlighted in green, goes there, it gets squared, gets doubled, and then you add 1. And so if you plug in a 2x plus 7, it gets squared, gets doubled, and then you add 1. Part B said, look, what is g of f of x? So now we're doing f of x first. If you plug in an x into f of x, well, it gets squared, doubled, and plus 1. And we can just write out that f of x is 2x squared plus 1. Now I'm going to rewrite g of x here. G of x was equal to 2x plus 7. And again, I'm going to highlight the idea that whatever you plug into g, well, it gets doubled, and then you add 7. So if you plug in all of this, that means that all of that has to get doubled and then add 7. This is one we could simplify quite easily, so I will. If I distribute that 2, I'm going to get 4x squared plus 2 plus 7 plus 9. It's not a perfect square, because if you did 2x plus 3 times 2x plus 3, you'd have to FOIL. It's tempting to make it a perfect square, but it's not. And then part C, which says figure out g of x. Well, we know that g of x is 2x plus 7. And now we're plugging a 2x plus 7 into g of x. What does g of x do? It takes whatever you put in, you double it, and then you add 7. So simplifying this, 4x plus 14 plus 7, 4x plus 21. Now the question also asked us at the beginning, once we're done, it says, then state its domain and range. So how do we state domain and range of composite functions? Well, for domain, one of the things we'd be looking for, are there any non-permissible values at any points in this equation? Are there any non-permissible values in g of x? Is there any non-permissible values in f of x? No. Once I did the composition, I get 2 times 2x plus 7 squared plus 1. Are there any non-permissible values in that? No. So our domain for A is everything. To figure out our range in A, this would most likely be a calculator question, in that you would have to find the vertex. You know that it's a parabola that's opening up. If I multiplied this out, okay, I'm just going to create some space up here so that we can see what it looks like when you multiply this out. 2x plus 7 squared will be 4x squared plus 28x plus 49 plus 1. And then this becomes 8x squared plus 56x plus 99. If you wanted to find the vertex without your calculator, you would have to complete the square. And it ends up being at a not very nice point. If we take out our graphing calculator and type this in, we can find our vertex. Okay, so I'm going to clear out this equation. I'm going to type in 8x squared plus 56x plus 99. And that doesn't show up as a very nice graph. Does that look like a parabola? No, so we might want to try some other zooms here. Maybe we want to try zoom fit, see if that shows up more like a parabola. No, so what did I type in wrong? There's a plus sign missing. That's huge. Yeah, because that'll make it a cubed. Okay, insert that plus sign. Not there. How about down there? So another nice thing, right? Because with technology, sometimes we do that. Sometimes we miss a graph. Now, how does that look like for a parabola? Not very good. I'm going to try going zoom 6 back to my standard window to see if that's enough to have it show up. Yes. But we knew it should be a parabola, and that didn't show up, so that's telling us maybe we typed something wrong into our calculator. To find my range, I'm going to need to find that minimum value. Second, calculate 3, the minimum. Go to the left side, -5. Go to the right side, -1. Find the minimum between there, and it's at negative 3.5, comma 1. That's not too bad. And so our range is y is bigger than or equal to 1. The second one is a little bit easier to figure out domain and range because the final equation that we got, which is 4x squared plus 9, is a parabola. Again, we've had no non-permissible values, so the domain is everything. And this one, just with transformations, you can tell me where the vertex is. It's a regular parabola, stretched vertically, and then shifted up 9 units. Can you see that your vertex would be at 0, 9? And your range is y is bigger than or equal to 9. So our transformations unit can come back and help us. And finally, the last one ends up being a straight line, no non-permissible values. So our domain is everything and our range is everything. Questions that you can try for practice are 10 and 11.